Hello everybody. Today I am going to discuss the most important part in this topic, that is the physical properties of liquid, that is the refractive index. Already you know that is when the light passes from one medium to other medium, what happens? It suffers refraction. What I am saying to you, that is when the light passes from one medium to other medium, it suffers refraction. That is what? That is change in path of direction. Okay. Now first we have to consider one medium. We have to select one medium. Second, we have to select other medium. And then when the light passes from rarer medium to denser medium, what happens? Or denser medium to rarer medium, what happens? In which these two mediums, we have to take the example, that is rarer medium, that is equal to a air example, and denser medium, which is of a solid, okay, liquid, okay, or it may be a water, okay. That is, for denser medium we have to show it in the point of by keeping the dots, that is in explaining the refractive index of a organic liquid by means of Pulfrich and Abbe's refractometer. What it happens? In that sequence we have to define this denser medium by means of a dot. Okay, got it? Now we have to draw one diagram to explain the Snell's law. Okay, see here. I will draw here the diagrammatic representation like this. See here. This is rarer medium. This is denser medium. Okay. This is the ray which is called as incident ray. And this perpendicular is known as the normal. Okay. This is a denser medium. Okay. That is, what happens here? When the light is incident with respect to a normal from a rarer medium to a denser medium, what happens here? It bends towards the normal. This is the normal. This is the incident ray. Okay. Here the incident ray bends towards this normal. It can change its path when it travels from rare medium to a denser medium. That is, in another words, we can easily say that is when light enters from one medium to other, what happens here? That is, it can suffer the refraction. Okay, that it can change its path of direction. Okay, now what actually forms here? Actually, what is the sequence? That is when the light is incident with respect to normal from rarer medium to a denser medium, it can pass in this way. Okay, in this way, but it is not happens actually at the certain points. That is, at the normal, it bends towards the normal, and what happens here? In this sequence, the light travels. Okay, and this ray is called as, that is, refracted ray. This ray is called as refracted ray. And the refracted ray making an angle with respect to a normal, it is known as the angle of refraction. Known as angle of refraction. Okay. Now our question is that what is the Snell's law? Okay. The Snell's law is nothing but the ratio of incidence angle and the refraction angle. That is, when light enters from rarer medium to a denser medium, at that time the incident ray makes some angle with the normal, that is, which is called as, this angle is called as what? That is the angle of incidence. Angle of incidence. Okay. Now what is the Snell's law statement? Here, see here, when the light travels from rarer medium to a denser medium, at the normal, the incident ray change its directions, that it suffers refraction, okay, and then the ray is refracted in this sequence. At that time, the angle of incidence, which is called as I, and the angle of refraction, which is called as small r. When we are taking these ratios, that is, with these ratios are which sequence? That is of sine sequence. That is, when we are taking the ratios of angle of sine angles of angle of incidence and sine angles of angle of refraction, which is constant through a liquid, and that constant is known as the refractive index. It is called as refractive index. And this is nothing but the Snell's law. What is the Snell's law? That is, Snell's law is defined as, in other way, see here, Snell's law, it is defined as the ratio of sine angles of angle of incidence to the sine angles of angle of refraction, which is constant through a medium, that is equal to Ri of liquid, that is equal to a constant value which is denoted by the letter small n, and this is known as the Snell's law. Okay. Now this Snell's law is already studied in your 12th standard. In other way, the Snell's law can be designated as here with the ratio of velocity of light. Okay, velocity of light divided by velocity of light and velocity of light in a vacuum. Now what is the second definition of the Snell's law? See here. Again, Snell's law is defined as, the Snell's law is defined as velocity of light in vacuum divided by velocity of light in a medium. Okay, that is nothing but the Snell's law. In other words, we can say that is N is equal to velocity of light in vacuum divided by velocity of light in a particular medium. Okay, that is, in short, the ratio of velocity of light in vacuum to the medium. It is called as the Snell's law. Now, actually, already we have studied that is N is equal to sine I divided by sine R. Now, what happens when I is equal to 90 degrees? Okay, this is the most important part we are going to see in the next lecture. That is, when I is equal to 90 degrees, at that time that angle is known as a critical angle. Which angle? That is a critical angle. When it happens in terms of a second criteria, that is angle of refraction and total internal reflection. Which are these two terms we are going to see in next lecture. Now when we are taking the I is equal to 90 degrees, what happens here? Sin 90 degrees is equal to 1. Okay. Therefore, this equation becomes n is equal to sin 90 degrees upon sin r. And we know that sin 90 is equal to what? That is equal to 1. Therefore, 1 upon sin r. What is the total relation? That is here, I am writing here. N is equal to 1 upon sin r. Okay. This is the condition for critical angle phenomenon or critical angle principle. This principle we are going to discuss in measuring the refractive index by using Pulfrich and Abbe's refractometer. Already this type of practical have provided in BSc part 2. Okay. Now we are going to see about the refractive index. See here. The scientist Pulfrich and Abbe devised or developed a refractometer which is called as Abbe's refractometer. Abbe's refractometer. Okay, and with the help of this Abbe's refractometer, one can find easily the value of a refractive index, that is equal to Ri, in very minute of time. Okay, that is for a specific organic liquid, specific value of a Ri. Okay, now the factors affecting on this Ri. Okay, what are the factors are here? Okay, now there are two factors on this Ri. First is the temperature. What is that? Is the temperature. Second is the wavelength of light. Wavelength of light used. Okay. Now, as the temperature is increases, these two factors are inversely proportional. Okay. That is Ri, that is equal to N, is inversely proportional to temperature and also a wavelength. Okay, that is refract array is increases with decrease in temperature. Decrease in temperature. Okay, also with decrease in wavelength. Okay, now generally the wavelength of a sodium, the sodium wavelength is used for the determination of a refractive index of a particular liquid. For example, D sodium Na20 means that is wavelength of sodium is used at temperature 20 degrees Celsius. Temperature 20 degrees Celsius. This is the notification of which wavelength we have to use for the determination of a Ri. Now the second point is that is what are the advantage. Okay, see here. What are the advantage? There are two advantages. The instrument is, first point is advantage. Instrument is easy to handle. Okay, Ri can be easily finding. Third point is there is no maintenance of apparatus. Okay, and specific liquid have it will have specific Ri value. Ri value. Once you standardize the Abbe refractometer, whatever may be specific liquid given to you, at that particular liquid have the same Ri value. Whatever may be the one student can determine this Ri value, second student can determine the Ri value. Ri values gets the same. That is, whatever may be the percentage gets changes, but Ri value does not change. Okay. Thus, these are the advantages. Now, what are the two types in measuring the refractivity? Refractivity, according to scientist Lorentz, Lorentz, according to scientist Lorentz, he developed the two refractivities. Which are the two refractivities? First is specific refractivity. Specific refractivity, and second is molar refractivity. Molar refractivity. We are just going on their formulas. Specific refractivity is determined by the relation that it is denoted by the small capital R, that is equal to n square minus 1 divided by n square plus 2 into 1 upon d. While the molar refractivity is determined by using the letter capital M, molar refractivity, or a Rm, specific refractivity is equal to Rs, Rm, molar refractivity, that is equal to n square minus 1 divided by n square plus 2 into M divided by D. Now, which are the quantities here? We have to just remind it. Where N is called as, you know, that is the Ri of a liquid. Ri of a liquid. What is D? That is density of liquid. Density of liquid. Now, the question is arises how the density is determined. First, you have to use the specific gravity bottle of 10 ml of each. You have to wet the empty specific gravity bottle. Then you have to wet the specific gravity bottle with water, and again you have to wet the specific gravity bottle with a liquid. Okay. After getting this, density can be calculated as, that is, weight of liquid divided by weight of water. Okay, and whatever may be its ratio, that is equal to the density of a given liquid. Okay, thus we have calculate the density. What is M? That is the molecular weight of the given organic compound. Okay, what is the M? That is equal to a molecular weight. It is equal to a molecular weight of a given compound. Okay, what is the molecular weight? That is the sum of its atomic weights. You are given the molecular formula. From this molecular formula, you can easily calculate the molecular weight. One by one, we can take the example of this molecular weight. See here, suppose we have to determine the molecular weight of a benzene. Okay, what happens? What is the formula? That is equal to C6H6. What are the atomic weights? Atomic weights of carbon is equal to 6. Hydrogen is equal to 1.0. How many carbons? 6. How many hydrogens? How many hydrogens? That is equal to 6. Carbon is equal to what is the weight? Sorry, what is the carbon is equal to weight? That is equal to 12. Okay, therefore 6 carbon, that is C6. H6 is equal to C into how many? That is equal to 6 plus H into how many? That is equal to 6. What are the weights? Here, these are the weights. That is equal to 12 into 6 plus 1 into 6. That is equal to 12 into 6, 72 plus 6. That is equal to 78. This is the molecular weight of benzene. Got it? Okay. Thus, you can calculate the molecular weight. What will be going to the density? Already we have discussed this, and in practical base we will discuss this density, how it is calculated by using the specific gravity bottle. Okay. Thus, we are considering with this specific refractivity and the molar refractivity. What is the difference between specific refractivity and molar refractivity? Here, in specific refractivity, RS is equal to what formula? That is n square minus 1 divided by n square plus 2 into 1 upon d. And what is about molar refractivity? Here, molar refractivity is equal to Rm is equal to, that is what? N square minus 1 divided by n square plus 2 into m by d. It is whatever may be the answer of specific refractivity, just you have to multiply it into molecular weight, you get the molar refractivity. Okay, this is the very much important factor in determining the molar refractivities of an analog of aliphatic compounds of a difference that is equal to CH2. Okay, that is specific refractivity and molar refractivity, which have the particular values. Okay, thus we have discussed in today's lecture what is Snell's law. Okay, how the Snell's law is based on critical angle principles. Okay, what is the refractometer and the refractivity types, that is known as the specific refractivity and molar refractivity. In next lecture, we are going to see the measurement of refractive index by using critical angle principle and its working by use of a Abbe's refractometer. Thank you.